Right, so in the last video we looked at empirical rule, and just to quickly go back over it, okay? Empirical rule states that if we have a group of data and we have a mean, well then 68% of the data will lie within one standard deviation either side of that mean, and it is 34% will lie to the below one standard deviation below the mean, and 34% will lie one standard deviation above the mean. Likewise, 95% of data will lie within two standard deviations of the mean, and 95 divided by 2 is 47.5. So two standard deviations to the below the mean will get us 47.5% of the data, and above again another 47.5% of the data. And almost all the data then lies within three standard deviations of the mean. Okay? Right. We're looking at z-scores now. So z-scores are, for one, they're more precise than empirical rule. Okay? And two, empirical rule will only allow us to find whole standard deviations. Okay? So as we see, 68% lie within one standard deviation either side of the mean. So but like, what about 1.5 standard deviations either side of the mean? So what if I wanted to find out the probability of getting data that lies in between these? Well, I can't do it using empirical rule. I need to transfer these standard deviations into z-scores, and then easily with my log tables I can transfer these z-scores then into probabilities. Right? Just very quickly, that's 0, okay, it's the mean. This then is, okay, so one standard deviation this way is z1, that would be a z-score of 3, of 2, and up here will be a z-score of 3. Okay, so again, z will equal 1 here, z will equal 2 here, and z will equal 3 here. And back here then, one standard deviation below the mean will give us a z-score of -1, two standard deviations below will give us a z-score of -2, and three standard deviations below will give us a z-score of -3. Right, hopefully that's fine so far. How do we get a z-score though? Okay, so we have our mean, which is given by this, and we take that away from our given score, and this will make more sense when actually doing it, and then we divide it all by our standard deviation. Right, and then we use, of course, our log tables to find the probabilities of z-scores. Okay, let's have a look at this question in green. So it says, in a class of students, their mean height was 165 with a standard deviation of 15. Okay, quick sketch then. Mean will be 165, standard deviation of 15, so that will mean one standard deviation above the mean will give us 180, two standard deviations will give us 195, three standard deviations will give us 210 centimeters. Okay, and likewise back this way, one standard deviation below the mean, 150 centimeters, another standard deviation below the mean is another 15 down, which is 135, and another standard deviation below the mean, which will be 120. Okay, so let's just say I wanted to find a person, find the probability of getting a person less than 180 centimeters. Okay, well, the probability of getting someone, I suppose, between 120 and 210 is almost everyone, so that will be a probability of 1. Okay, so if you bear this in mind, the whole normal distribution curve has a probability of 1. So that means getting someone with a height of less than the mean, okay, and the mean is halfway, would be 50%. Right, so we're looking at getting a person less than 180, so it's from 1 standard deviation back this way. Well, here we have 50%. Okay, so we definitely have 50% of it. Plus, and we know that this is 34%. Okay, because 1 standard deviation either side of the mean is 68%, and half that 34. So plus 34%. And if we add them together, we'll get 84%. So I have an 84% chance of getting less than a person in the group that's less than 180 centimeters. Okay. If we change that into a probability, it'll be 0.84. Okay. So that's how we did it with empirical rule. Fair enough. Let's change that into a z-score though, and let's use our tables. Okay, we'll see how we can get it more precisely here. Right, well, how do we do that? Look up at our formula. So I'll actually do it over here. We'll do it here. So z equals, well, the given score, and I want to find someone that's 180 centimeters high. Okay, or z-score for this 180, minus the mean, and the mean is 165. Standard deviation is 15. That would give me 15 over 15, which equals 1. So the z-score of 1. Good. Now, this is how I turn my z-score into a probability. First of all, we have to decide what we'll actually do with the z-score when we get it. So we go to our log tables, and we're looking for a z-score of 1, and it's not 1 point something, it's just 1. So here we go, we look at our z-scores, here they are, we go to 1, it's 1.00 because it's exactly 1, and there it is. So that's the probability of us getting what is it, a person with height of less than 180, 0.8413. So I'll do that in green. So 0.8413. Now have a look at this. It's very close to what we got using empirical rule, but it's a little bit more precise. Okay, hence why I was saying z-scores are actually better than empirical rule to use. Okay. Right. Now let's look at a question that I can't use empirical rule for at all, that I have to use z-scores for. This question is 84 centimeters in height. Okay, so I want to find the probability of choosing someone with a height of 84 centimeters. Okay, so 84 centimeters is going to be somewhere around here. Oops. Okay, so as you can clearly see, this line that I've drawn here for, what was it, 184 centimeters, that does not lie on a whole standard deviation. The last one did. The 180 was exactly on 1 standard deviation, so that was easy enough. I could have used empirical rule there, okay? But I used these z-scores as well. But this one, this 184, this lies here, so I have to use a z-score for this one. So with this in mind, I'm just going to change this quickly. So instead of 180, it's 184. So that will be 19 over 15, which gives me a z-score of 1.26. We go to 2 decimal places. So there's my z-score. Right. Go to my log table, see what 1.26 is. So have a look here. 1.2 is here. So there's 1.2. But it's 1.26, so I have to go over to this and go down, across. So there it is. So it's 0.8962. 0.8962. Okay. So 0 probability of getting someone with a height of less than 184 centimeters is 0.896. 0.62. Okay, so these z-scores are very easy. Okay, just one other thing. In both of the questions we had there, basically we had a z-score that was to the right of the mean, so it was higher than the mean, and we were looking then to find the probability of getting less than that. So we were looking to go probability of everything before that. And if that's the case, so if I have, let's say, I'm looking for a z-score that's to the right of the mean, and then I'm looking for the probability of getting less than that, so basically all this back here. Well, that's fine, because I can just read the z-score straight from the tables. Okay, so for example, probability of getting less than 1.49, I just go to the tables, look at 149, 149, which is here. So it's 0.9319. 0.9319. So 0.9319. However, if we look over on this one, we again have a z-score that's to the right of the mean, but this time we're looking at getting the probability of getting more than that score. So more than that score will be all of this here, as opposed to what's behind it. But remember, I said the probability of getting something in the whole curve is 1. So if the probability of getting something behind that score is 0.9319, well then if I just take this here away from 1, I want to get everything on this side up here. Okay, and look what our formula says, it's 1 minus the probability of the z-score of 1.49. So if I just take 1 minus, and the probability of the z-score of 1.49 is 0.9319, which we're going to do in the calculator. So it's 0.0681. So that's the probability of getting more than 1.49 on my z-score. Back here then. Five minutes. The reason I can do the same for this as I can for the one up here is because the curve is symmetrical, right? So basically this one that I already did here will actually have the exact same result as the one down here, because it's the exact same area on the curve. It's just one of them is up at the top of the curve up here and the other is to the back of the curve down here. So it's meant to be 9. Okay, but here let's do it anyway. So we have 1 minus the probability of getting the z-score of 1.49, which was 0.9319, which gives us 0.0681. Okay, and if my drawing was a bit better, this here would be the exact same size as this here. Okay, right, last one. This time we're getting the probability of getting between two z-scores. So I have a z-score here, I have a z-score here, and I'm looking for the probability of getting between those. What do I do? Well, first of all, I will get the probability of getting to the left of this z-score, so all of that. And how did I do that? Well, just the same as I did it up here. Okay, just read the z-score straight from the tables, and it was 0.9319. So 0.9319. And now what I want to do is I just want to take away this bit from it. So if I can just take away this bit from it, then I get this. Okay, how do I take away, or how do I get what this bit is? Well, just like I did over here. Okay, and I found that out, and it was 0.0681, and I'll just take one from the other and I get my answer, and that will give me 0.863. Okay, so there is that probability of choosing someone that's in here, basically. Right, so a few very quick questions to do. The ones in red, I'm going to use empirical rule. Right, could use z-scores, but let's just use empirical rule to be quicker. The questions in green, I'll use z-scores. Okay, find the probability of, well actually I'll read the question first. Milk cartons are designed to hold 1000 millilitres, which is a litre. However, they're not always exactly 1000 millilitres of milk in them. Okay, sometimes it's a bit more, sometimes it's a bit less. Due to errors, some are slightly more than 1000 millilitres, some are slightly less. It was found that the mean amount of milk in the cartons was, in fact, 1000 millilitres. However, there was a standard deviation, okay, so they differed sometimes. And that was 15 millilitres. Right, so let's just sketch it out. So we have 1000 millilitres on the mean, so a z-score of 0. At z1, we take away 15. So that will be, sorry, we add 15 because it's to the left, it's more than the mean. So it's 1015. Add another one for z equals 2. And that will be 1030. And add another standard deviation for z equals 3. And we've 1045. To the left now, take away one standard deviation for z equals -1. And we were left with 985. For z equals 2, take away another standard deviation, left with 970, and take away another standard deviation for z equals -3. These are minuses, and that will be 955. Okay. Find the probability of getting a carton of milk between 985 millilitres and 1015. Well, that is actually between one standard deviation either side of the mean, so that will be black 68%, which is 0.68 probability. Next question. Find the probability of getting a carton of milk less than 1015. So basically less than this. So all back here we're looking for. We could look at our tables. We have a z-score of 1 because it's exactly one standard deviation. We could look for the z-score of 1 and find out what the probability is. Or we could say, well, from here is 50%, because it's half the curve. And we know then this is an extra 34%, because 34%, 68% is of the data lies within one standard deviation of the mean, and there's half of it, so 34%. So that will give us 84%, which is actually 0.84. If we looked at our tables, we would realize that it's actually 0.8413. Okay, so the tables are more precise. But we'll just leave it at 0.84. Find the probability of getting a carton of milk more than 130. So let's tidy this up a bit. More than 130. So there's 130. More than that. So up here. Okay. Again, the whole curve is 1. So if I can get the probability of getting less than 130, so all of this, take it away from 1, I get my answer. Right. Well, let's fill in some of it. Well, I know up to here is 50% anyway. So also up to here, look back. Oops. Let's have a look at up here. Look at that. 2 standard deviations, 95% of the mean. So that was 38 either side here. But remember I said from here to here would be another, what was it? 5. It's 47.5. Okay, so 47.5. So this is 50%. This here then, from here all the way up to here, so I'll shade it in, 47.5%. So we have the 50% up to the middle, and then plus the 47.5%, which will give us 97.5%. Okay, so 0.975 it is as a decimal. Okay. Let's check it on the tables though. Okay, we're looking for z equals 2. So z equals 2 is here, so 97.72%, which is 0.97, go back again to it, 0.9772. Okay, so again, the z-scores are a little bit more precise. As I said, this is not an exact science, okay, it's not always 68%, it's thereabouts. Right, now, in these green ones we're going to have to get z-scores, because in these ones we could use empirical rule, or we could just read the z-scores 1, 2, 3 of our tables. Right, first one, find the probability of getting a carton with less than 1.10 milk. Okay, well, 1.10 is shaded in, so we'll know what side it's at. Right, so less than 1.10, 1.10 is about here, and it's less than that, so it's going back the way. Okay, we need to put it into our formula for z-scores. So z equals, well, the score, which is 1, 0, 1, 0 I'm looking for. Yeah, there it is. Minus the mean. Let's look at the mean, what it was. 1,000. So minus 1,000. All over, and standard deviation was 50 if I'm mistaken. Yeah, 15. So that will give me 10 over 15. And that equals 0.66. So there's my z-score. Right, let's check my z-score and see what it is. 0.66, so there's 0.6. 0.66 is over here. So it's 0.7454. 0.7454. So there's the probability. And let's just check now. Again, our mean, our z-score is to the right of the mean, and we're looking for it to be less than that. So if we check over here, it's this one we're talking about. And with something like that, we just read the z-score straight off. So there's nothing more I have to do. So there's the answer to question 1. 0.745. Right, the next question. Should be question 5. And that should be question 6, and that should be question 7. Right, question 5. Find the probability of getting a carton with more than 1010 milliliters. So in this case we're looking for not what's below this point, but what's more than that. Check up here, we're talking about this one, and in this one we find our z-score, we find the probability, and we take it away from 1. So I'm after finding the z-score already, which is here, so all I do is take it away from 1. So 1 minus 0.7454. Do that in the calculator. And give me 0.2546. So that's my probability of getting a carton of milk with more than 1010 milliliters. So in 0.2546. Right, next question. Question 6. Find the probability of getting a carton of milk with less than 985 milliliters in it. Okay, so this time we're not looking at this 0.15 milliliters anymore. We're looking at, what is it? 0.85. Okay, actually, do you know what? It's too easy. Let's change that, okay? Because that's just a z-score of 1. Let's change it to 982. Probability of getting a carton of milk with less than 982 milliliters. So that is about here, say. So it is less than the mean, so it's to this side of the mean. And we're looking for the probability of getting less than it. So if we check here, it's going to resemble this. So it's 1 minus the probability of our given z-score. Okay. So we get our z-score. Okay, we get rid of all this. Let's get our z-score. So z equals, well, the number, which is 982, minus the mean, which is 1000 all over 15. That will give us 17 over 15. Use our calculator then. It will give us it's minus 17 actually, so it'll give us minus 1.13. So there's our z-score. Okay, now let's look back, because we have a minus z-score here. So what do we do in this case if we have a minus? Well, all we do is we get the probability of the positive version of that z-score and take it away from 1. So a z-score of 1.13. Let's see. 1.13. That's here. So it's 0.8708. So 0.8708. 0.8708, and we just take that away from 1. We get 0.1292. So there's my probability of finding a carton with less than 982 milliliters in it. 0.1292. Okay. Last one then. Right. We'll stick with the 8 2 actually. Okay. So we're looking for the probability of getting a carton with between 982 milliliters and 110 milliliters. If we look back here, it's this one we're talking about. Okay. So what do? We find the area to the left of this. So I have to tidy it up. So if we want to find between this and this, we find the area to the left of that. Then we find the area to the left of this, and we take it away. Okay, so let's do that. So find the area to the left of 1010. We found that already. 0.7454. Find the area, the probability of to the left of 982. We found that already. 0.1292. Take them away from each other. 0.7454 minus 0.1292, and that will give us 0.6162. So that is the probability of me getting a carton of milk with between 982 millilitres and 1010 millilitres in it. Okay, so 0.6162. Okay, that's it, guys. Thanks.